Hi, my name is Kavya. Today I'm going to discuss about Spring and Spring Boot framework. Here, um, sorry, due to some time constriction, uh, last video you have discontinued with us half of the part of the Spring Boot concepts. We are discussing in Spring Boot basic technologies standalone application and web application, monolithic applications. These four applications we are discussing in last video. Today here we are discussing about the remaining application. Now I am going to share my screen. Ready? Share. In last video, we are discussing about the basic technologies of the Spring. We have stopped with the third application, SOA. Due to some time constraints, we are discontinued this topic in the last video. In this video, we are continuing these topics. These the remaining three applications like SOA, service-oriented architecture, and microservices applications, and fifth one is web services application. First, we are discussing the SOA, service-oriented architecture. Service-oriented architecture is an architectural pattern in which software components called services are designed to provide specific business functions and communicate with each other over a network. These services are independent, reusable, and loosely coupled, meaning, meaning they can be developed, deployed, and maintained separately. In this service-oriented architecture, we have some key characteristics. They are one is one is modulability. Ability. And second one is loose coupling. Loose coupling. And the third one is interoperability. Interoperability. And fourth one is discoverability. And okay, discoverability. And the fifth one is scalability. ALT. We are discussing these five key characteristics of the SOA. First one is modulability. Modulability in service-oriented architectures, each service is a self-contained unit that performs a specific tasks and can be reused across different applications or systems. Second one is loose coupling. Second one is loose coupling. Okay. Okay. Loose coupling. Services are independent of each other, meaning changes or failures in one service do not directly impact others. This enables more flexible and scalable system architecture. And third one is iterability, interoperability. Services in service-oriented architecture communicate with each other using standardized protocols such as HTTP, SOAP, SOAP, or REST, allowing for integration between different platforms, programming languages, and technologies. Fourth one is the discoverability. Services are often registered in a central directory, allowing other services or applications to find and use them dynamically. And the fifth one is scalability. Since services are separate, individual services can be scaled independently to meet demand, which can improve overall system performance and flexibility. Example of the SOA architecture application is in a e-commerce application, you might have separate services for user management, order processing, payment processing, and inventory management. Each service can work independently but communicate with others to complete tasks like processing an order. Service-oriented architecture is often used in large enterprise systems, where it helps streamline development, enable integration across the different systems, and improve maintainability. This is the example of the service oriented architecture. Now we are going to discussing the microservices application. Microservice application is an architectural style where an application is developed as a collection of small, independent, and loosely coupled services. Each service is focused on a specific business functionality and can be developed, deployed, and scaled independently. Microservices communicate with each other over a network. యాడికి పొద్దుగుకులు వస్తారు మీరు అమ్మ అప్పే పో. ఏదో చదువుకుంటున్నా కదా సరే Sorry. Microservices communicate with each other over a network, usually via lightweight protocols like HTTP, REST, or messaging systems. Microservices applications have some key characteristics. These microservices application they have five key characteristics. One is independence. And second one is loose coupling. Sorry, loose coupling. And third one is independent deployment. Independent deployment. And fourth one is technology agnostic. Technology agnostic. And the fifth one is scalability. These five are the key characteristics of the microservices application. First, we have to discuss the independence. Each microservice is a small, self-contained unit that handles, sorry, that handles a specific task such as user authentication and payment processing or order management, like that type of uh, units this we are we are managing the in the independence. Second one is loose coupling. Microservices are loosely coupled, meaning they interact with each other via well-defined APIs, but not to rely on one another's internal implementations, making it easier to change to upgrade individual services without affecting the entire system. In this we are discussing the second one, loose coupling. Loose coupling microservices are loosely coupled, so meaning they interact with each other via well-defined APIs, but not rely another, but not connect with internal implementations, like making it easier to change, affecting. Third one is independent deployment. Third one is independent deployment. Here we are looking the since each service is independent, it can be developed, tested, deployed, and scaled separately, which make the system more flexible and easier to maintain. Fourth one is technology tech, technology agnostic. Different microservices can be written in different programming languages or use different storage systems depending on the needs of the service. Sorry. In these microservices characteristics, fifth one is scalability. Microservices can be scaled individually, meaning that if one service is under heavy load, only that service needs to be scaled rather than the entire application. Sorry, we have in these characteristics, we have the sixth characteristic, that is sixth one is resilience. Resilience. I forgot that in the that is in resilience. If one micro services fail, the other can continue to function, leading to better fault tolerance and system reliability. In the resiliences, we have we have got one microservice has got failed. It, the service cannot stop that service as the next microservices can go to leading with another better fault tolerance to system reliability. Example of the microservices application is in an online shopping platform. You might have separate microservices for handling. One is user management. For authentication and profile updates purpose, we have used the user management. Second one is product catalog. We have for product details, we have to we have to look for the product details. We are go to using the product catalog. Third one is order management. for ordering and order creating, for order tracking and past orders to look at the past orders. We are using the order management. Fourth one is payment services to handle the payments. Transactions like postpaid or prepaid, this type of payment services, we are using the payment services. These are the examples of the microservices applications. Fifth one is a web services application. Web services application. In a web services application is a software system that allows different applications or systems to communicate with each other over the internet using standardized protocols, typically HTTP, and data formats like HTML or JSON. Web services are designed to enable interoperability between different platforms, allowing applications to exchange. Here we are show the exchange data and perform operations regardless of the underlying technologies or programming language. This is the brief info about the web services applications. In web services application, we have some key characteristics. These are one is for one, communication over the web. First one is a communication, sorry, over the web. Second one is, sorry, second one is standard protocols. And third one is platform and language independence. Platform and, sorry, language independence. Then, sorry. And the fourth one is interoperability. We are discussing the web, this interoperability in microservices. Also, we are discussing the interoperability. That is, and fifth one is request and response models. Request and response model. These are the key characteristics of the web services applications. Here we are going to discuss one by one. First one is communication over. Sorry, over. Okay, communication over the web. Here we are discussing the first one, communication over the web. Web services use the web, usually HTTP and HTTPS, like that. Webs we are using we are HTTP and HTTPS, like that. These services we are using for web services as a communication medium, allowing them to be accessed remotely by clients from anywhere. Second one is standard protocols. Web services commonly use standards like SOAP, Simple Object Access Protocol. SOAP full form is a Simple Object Access Protocol or REST. REST means representational state transfer. REST full form means representational state transfer for communication with RESTful services being more common in modern web applications due to their simplicity. And third, we are going to discussing the platform and language independence. That is, web services are platform agnostic, meaning they can work across different operating systems and technologies as long as the systems adhere to the communication protocols. This is the info about the platform and language independence. Next, we are discussing about the interoperability. In this interoperability, we are discussing in the SOA, service-oriented architecture applications. We are discussing interoperability. Now we are discussing in the web services. These two have the same one of the same key characteristics, but their performance is separate. In this web services, interoperability is allow different applications, possibly developed in different languages, are running in different platforms. Example: Java, .NET, Python, etc. to communicate and share data. This is the interoperability functionality of the web services application. Next, we are going to discussing the fifth one, request and response model. In this request and response model, a web service typically exposes a set of functions or endpoints that clients can invoke. In request and response, that clients can give us to some endpoints. To reach that endpoints, we are using this characteristic. The client sends a request usually via HTTP. The client can give the request and service response with the result, often in XML or JSS format. The client can give the HTTP format or JSON format or XML format can give. This is the request and response model of the response model characteristics of the web services. Here we are discussing the web services application example. Is an example of a web services application could be an online payment gateway. This is the perfect example of the web services. The payment services might provide a web service that allows e-commerce websites to send a payment request with details like amount and payment method to the service. The service processes the payment and sends back a response indicating whether the payment was successful or failed. And web services applications are widely used in system integration, enabling communication between different applications. Third party services like different languages and different operating systems or different hardware parts. This type of third party systems can give the possibility to external system in decoupled and standardized way. This way, we can use these applications to build a Spring Boot Spring framework. And these are the five application terminologies to build a Spring Boot framework. Here we are going to, sorry, okay. Here we are see the applications and the features of the Spring in official website also. We are going to see this info about the in okay. By following these five application technologies, we are going to build this type of frameworks. Here we are see the Spring. by VMA Thanju. Using this terminology, you can make these many types of popular applications by Spring Boot most powerful. Why? Because the we are by following these five terminologies, we are going to build this Spring framework. Spring. Sorry. Here we are going to see this framework, Spring framework. Here we are going to why Spring is very powerful is they can give the rapid application development. Everything will be done is in so fast way. So that way, Spring Boot framework is very powerful in the market, and by using these five terminal by and the Spring, sorry, here Spring can do these many types of applications. We are going to discuss some applications in past. Here we are going to see there's so many applications. These like microservices, reactive, cloud, web apps, serverless, event-driven, batch, like that of applications. Spring can work. And okay, here. Okay, and so, by following these terminologies, we are going to see this Spring framework. The Spring framework overall view is this is the overall view, and we can see the features, Spring policy migrations, and features of the Spring core technologies. Here we can see these core technologies of the Spring and testing mock objects like data accesses, Spring MECs, and integration languages. This type of features we can see. This type of features of the Spring we can see here, and we are see these many projects. Here we can see the Spring Boot project also. That is here we can see Spring Boot project. Overview of the Spring Boot project is here. This is the overview of the Spring Boot project. That is here we can give some explanation of the Spring Boot. That is, Spring Boot makes it easy, created standalone, productive, great spread basing, Spring based application that you can just run. Spring Boot can give the rapid application and some ready-made code, so they can give the just an application. So here we can see the just an application. We take an optional opinionated view of the Spring platform and third-party libraries, so you can get started with minimum uses. Most Spring Boot applications need minimal Spring configurations like the project releases, notes, session. Also, we can here Wikipedia. Here we can see the Spring Boot features and how can we start the Spring Boot talks and videos we can have here also. This is the Spring and Spring Boot. How can here we can learn the Spring Boot and samples, few examples to try here. Here we can see the versions of the Spring Boot. These many type of infos we can have. We can build by using this basic terminal. By using by using these basic technologies, we can build this type of frameworks, Spring and Spring Boot. Here we have some different types of projects. All projects we can see here. Also Spring Framework, Spring Data, Spring Cloud Data. This type of projects we can see here. We can see here. So this is the explanation about the Spring and Spring framework and the basic technologies we can explain in this video. Thank you. In this video, we have seen some basic technologies of the Spring Boot, and we have seen the Spring Boot frameworks, and we can have this some how to which type of technologies using how to build a Spring and Spring framework by following some basic technologies. We are discussing these basic technologies in this video, and we have some conference about the Spring and Spring Boot also. This is the video. This is the Spring and Spring Boot framework and basic technologies of this framework we have discussed in this video. Thank you.